In this video, we are going to study free body diagrams. Now there's a problem here. Let's solve this problem. Find the forces at A and B according to this frame. Okay. And what is here? 5 kilonewton per meter each member weighs. It means that these 1, 2, 3. We have 3 sticks or 3 bars. So these are produced from the same material, and 5 kilonewton per meter means each 1 meter is equal to 5 kilonewton. So if it is, for example, 2 meter, it means 10 kilonewton the weight, like this. Okay, now the main problem is find the forces at A and B. This is the frame. First, let's draw the free body diagram. Free body diagram, as you can see here, the weight of this load, this external load, and the weight of this stick, and it is acting at the middle of this stick because this is homogeneous. This 4 plus 2 means this bar or this stick is 6 meters, and the center point is 3 meters. So it means from here to here it should be 3 meters. For what? For the weight. And as you see here, this is 3 meters, and here 1 plus 2 means 3 also. And how about the other? This stick has a gravity center here 2 meters from the point B or point A, from this X. Why? Because from here to here which this stick is acting is 4 meters. For that reason, half of it is 2 meters. So this weight of this bar or weight of this stick is acting on a place which is 2 meters from this axis. And there is the weight of AB, this one. This stick AB, but it has the distance of 0 meters. So in the momentum we will not use this, but as a free body diagram it has to be shown on the system, or it can be shown from here also, like a vertical. Okay, this is the solution part. First of all, let's find the length of this bar, FD, because this is not given to us. But it is easy to understand because this is a simple triangle. 3, 4, and what is this? Hypotenuse 5. We calculate the hypotenuse from here, and you can see that the length of this bar is 5 meters. Okay, now how we will use this? We will use this length to calculate the weight of this bar, which is acting like this, which is acting here like this, and we call this as this is dF, weight of dF bar, weight of dF stick, and it is here 5 meters. And now let's find one by one the weight of the members. Okay, we find the length. This is length, the size of the bar, length is 5. Okay, how about the other 5? This 5 is coming from here, 5 again kilonewton per meter. Let's write the units. So this, when you multiply this m and this m is deleted. Resting is kilonewton. So 5 times 5, 25 kilonewton. So here in this graph, in this figure, WDF, weight of DF, weight of the bar DF is equal to 25 kilonewton. This is given to us, no need to calculate this. And now we calculate the weight of CE, this bar. We will calculate, and you see the CE bar is 312 is equal to 6 meters. The length is written here, 6 meters, and 5 comes from here. The weight for 1 meter, the result is 30. And then weight of AB, A to B, again it is 6 meters, this is L6 times 5 for 1 meter weight, it is 30 kilonewton. So we find the weights of the members. Now let's continue for solving our problem by calculating the A and B forces. A, B are shown here. In order to find the forces, first we will use the momentum formula. Let's take momentum from the point B. This is point B, and let's think about the forces acting on this point. First of all, WVC times 3. this length, and this length 3 meters, and the force is WCE. We are taking momentum for the point B. It is here. And next, WDF. This force, it has 2 meters of length, and next this force, which is 200 kilonewton, and it is acting on 312, means 6 meters, from 6 meters. So when we put the numbers here, we calculate the A horizontal. Yeah, of course, A horizontal has 6 meters length here. This is minus, this is plus. Let's think like this. And because of the equilibrium, 6A horizontal is equal to this part of momentum. And when it is calculated, we find AH as 223.33 kilonewton. This is step 1. And then we have to calculate BH. Okay. BH is here. From the equilibrium formula, BH is equal to AH. B horizontal is equal to A horizontal. So in this direction, horizontal direction, there is no any other force. For that reason, BH is equal to AH. And we find this AH force, so it is equal to 223.33. Same number with AH. Now what is left? B vertical is left. So let's find the B vertical by using the other equilibrium formula, which is here. Vertical forces is equal to 0. This is the formula or theory of equilibrium. Okay. What do we know? Here we know all the weights, the lengths, the external force, AH. So actually AH is not used here in the vertical forces. We can use A vertical as the weight of this AB bar. Let's write our formula. B vertical is acting like this. B vertical is here, acting like this. And what is here against to it? There is VAB, weight of AB here, plus weight of CE, like this, plus weight of DF here, weight of DF, plus the external force, 200. And if you do the calculation, you get the result for vertical force of BV, which we call BVB, vertical force of point B. This is, as you see, a very simple calculation method. Now let's see another diagram. Can you draw the free body diagram of this? Yes, it's very easy. You can draw like this. There are two A and B points. A is pinned support here. That's why it has X and Y, which means horizontal and vertical point. And this is B is roller support. That's why it has only B horizontal. And there is G, the weight of this bar, and it is acting like this, and we have 2400 kilogram. And in free body diagram we write it as kilonewton. How we calculate this? 3.5 from here. You know, the gravity acceleration coefficient is 9.81, and if you multiply it with the weight, here it comes the kilonewton result, and we write it to the free body diagram. Okay, we are not going to calculate this. This is only FBD, free body diagram drawing. Next, you can see there is a human part here, an arm, triceps muscles, biceps muscles, and it is holding a book of 4 kilograms. And of course there is the weight of your body part. It is given here as 2.5 kilograms. And it is acting on this gravity center, which is given to you as 16 centimeters, and the length from your elbow, from your joint, is given as 38 centimeters. Here, free body diagram, we have FB force, which we have on our arm to upwards, and FE, which is triceps muscles, which gives you the weight. It is caused because of the weight of the book and the weight of the body part. It is FE, and B is the weight of the book. VA is the weight of your body part. This is the hint for free body diagram. Now let's look. Yes, the forces, the direction of the forces, and the lengths given here. Yes, this is free body diagram. That's all. There's no calculation here, but I give you a homework to find the momentum at the elbow. So now you have to calculate the system. You have to calculate the system. This is your your homework. Find the momentum at the elbow. Please do your homework and submit me to email. Thanks for watching.